Testing. Okay, I'm really sorry, guys. My computer wasn't detecting my headphones, so I've been talking to myself for a good 7 minutes here. Just as soon as you don't hear anything, put something on Discord, please, immediately. Because I have a Bluetooth headset, so sometimes the computer just kind of forgets that it's there. I've been using the same headset all day long, but it just sometimes decides not to do it. Okay, so let's go over this again. So I was saying that you could go to my repository. I've selected an example program that's very simple. It's just called main.c. What I am doing in the repository is that I'm viewing the raw version of it, Control-A, Control-C, copying the whole thing to put it on online GDB and running it there. And when I do it on online GDB, I get the false impression that it's a single thing that happens, that you just run and magically you get the result. It's a little bit misleading because actually it's a two-step process. And today we're going to be concentrating on that two-step process. So let me leave the Linux and show you again on the Mac. I will remove the old file. I will remove the old executable. I'll show you guys the files that I have. Okay, I don't have any files like demo. Okay, so I'm going to use my editor. I use Emacs. You can use the editor you like. A lot of people like, what's it called, Visual Code. Some people like Atom. There's a lot of editors. Just get one that doesn't charge you money and isn't pirated, like a legal free one. So I'm going to put the code to demo.c. I'm copying all the code there, saving the file, and I'm leaving my editor. At this point, I will compile the code. I'm going to use a GCC, which is a GNU-C compiler, to compile my code. When I compile it, it generates this file, a.out. And then I will execute the a.out. I can notice that it printed the hello world and it put like a % at the end of it. Going to enter another computer. I am now on a Debian Linux computer, which is the computer that hosts the website. We're going to do the same thing here. Let me just delete the file so we can start over. Okay, so I'm going to use the same editor Emacs to make a file demo.c, copying the source code, saving, closing the editor, using the same compiler GCC on a different computer in a different operating system. It's created me an a.out. I execute the a.out. Now it didn't put any % and it glued together the hello world with my username. So let's modify the code to include a new line. So I'm going to go back to edit the demo.c. I'm going to tell it, print me this followed by a new line. Let's add a comment here to explain. Minor formatting, I have saved and I'm closing the file. If I run the program again, it's still the old version because to update the executable file, I need to recompile. After I have recompiled, I now have a new executable version. I can do the same thing on the Mac. I'm leaving the Linux. I am modifying demo.c in my text editor to have the \n, making the same format changes here, compiling again, and if I run it again, I now have the updated version. On Windows, when you use a compiler, it usually produces an executable called a.exe instead of a.out. If I want it to be called something else, I could tell GCC I want it to be called something else. So now it's not a.out anymore, it's something else. You can do the same thing as well. You can make it called whatever you want to, but in Windows, it's never going to execute it if it's not called .exe at the very end of it. So how would you do this on a Windows computer? And how else could you do it on a Mac? Mac should also have a CLang, which is another compiler. So I should be able to compile with clang just the same. And now clang has updated my a.out. I will prove this to you guys. Now there's no a.out. When I run clang, there is again an a.out. So my clang is actually doing the same thing as my GCC is doing. I can look at where are they on my computer. I have a GCC and I have a clang, and those are different compilers. I have two different C compilers on my Mac. For you to install a C compiler on your Windows, I was linking it here before. I would recommend you to use this one. There are other options, but last semester several people used this one. It's roughly up to date and it's free and it's open source, the code blocks. So a lot of people on Discord will be able to help you with this. It's a good starter thingy to use. So you're going to go to downloads and you're going to pick which version you want. You're going to want a binary release, meaning you can just install it. You're going to want to install this on Windows. If you're in Linux or Mac, we're not going to use code blocks. We're just going to use GCC or clang. If you are not the administrator of your computer, or you do not know what it means to be an administrator of your computer, you're going to choose the non-admin version. I usually download from SourceForge. If you are the administrator of your computer and you know exactly what that means, you can get the first one. I cannot show you the steps of the installation because I'm not in Windows. So if you have any trouble with the installation steps, you can watch this video that I have linked for you on how to do this. Once you have installed code blocks, you will do what it says here. You're going to click on the file menu, click New, create an empty file. You will copy paste there the code from my repository, the one that we were just looking at. Let's go back there to GitHub, to the C repository. I was in the chapter 1 and I was working with the main.c and I was looking at it in the raw mode. So you're going to copy paste this information into the empty file. You're going to save it, called something like demo.c. Please don't put any accented characters or empty spaces in your file name. That's a bad idea. Call it something simple. Then you will press F9 and code blocks will compile and run your program. This video will also explain what's the difference between just compiling or just running or doing the both of those things. So if you are able to download software and install software on your computer, please do that now. If you are unable to do this because your internet connection is bad or you cannot install anything on your computer, you will simply skip this step. I'm going to make a poll. I have installed code blocks. You click on green if you're in Windows and you installed it. If you cannot install it for some reason and you are in Windows, put the confused face. If you are in Mac or Linux or you already have a C compiler, put the sleeping face because none of this involves you. If you have a question regarding how to download and install code blocks even after you already watched the video, you will click on the question mark and write your question. I'm going to be staring at this Discord for a little while to make sure that everybody is on top of things. We're going to take a little break from the stream so that these people have time to download and install. And in 4 minutes, I will continue explaining. When you guys have been able to install your code blocks and compile and run this, please paste a screenshot of what you did on the Discord channel so that we can see that it's already working. A very good tool for taking a screenshot of just a part of your screen is Screenshot. My boyfriend recommended this to me. Mac does it automatically, Linux does it automatically, but you need to install a thingy in Windows to get it working to select a part of your screen for the screenshot. But I would like to see in code blocks the editor part, the part where you have the content of the file, and the part where it actually printed the hello world. And I would really like it if you guys could make a tiny little change in the file so that it prints a slightly different thing. You could, for example, make it so that it prints your own name. And then when you recompile, really important that you remember to recompile and execute, you can see what it's actually saying. So please let's get screenshots of all of this stuff working. So that way you already know which people have it working and you can ask on the voice chat if they could walk you through it. If you're having trouble on your computer, if you're seeing an error that you do not understand, on the voice channel, what you can do, I'm going to show you guys how. I'm going to mute myself so you don't hear me double. When you choose to join a voice channel, you can share your screen. If I click here, I can select which monitor or which program I want to be sharing. So let's say that my code blocks would be on my screen too. I could select the resolution. I'm going to scale it down a little and the frame rate, and then I can go live. Other people can click on the red button to look at what you are streaming. So now this is what it looks like, and this is what I am sharing on Discord. It's my second monitor where there's the OBS and the Twitch dashboard, okay? And then if you don't want to share that anymore, if you want to share something else, you can change the windows, change the quality, or stop streaming. So if you have any kind of difficulties, other people can easily help you. If you share your screen, they click on your stream, they watch your stream, they can see the error, they can see what's going on. If you don't want to or you're unable to share your screen, then you can simply take a screenshot and post it on the channel. I'm going to leave the voice channel for now, so I won't talk over you guys if you need to do something there. But I would like to see at least 5 people screenshots of their code blocks already working to have some faith that we can actually talk about other stuff. Because if nobody gets this working, it doesn't make any sense for me to start talking about something else. I'm going to give you guys another 6 minutes. At 3 o'clock, please, let's have 5 people working and those 5 people helping the other people so that everybody gets this installed. Okay, I'm still waiting for progress here. A lot of people have been installing stuff, but I'm thinking they only have the front end, they don't have the back end yet. If anybody needs help, please let me know. There isn't much we can do until we have this part running. For the first homeworks, we're just going to be happy with just one C file, so it's going to be just as easy as it is now. Is it maybe that someone doesn't know how to take a screenshot? Or nobody wants to take a screenshot? It would be really helpful to know what you guys are up to. Let's try another poll. If it's working and you just don't want to show me, click on the green mark. If you need more time, it's about to happen, but it hasn't happened yet, click on the confused face. If you have a question that you need me to answer, question mark. So one person is still working on this. One person has it done. One person has a question. Wonder what all the other people are doing. Okay, 2 people are ready, but they don't want to show it on screenshot, which is a mystery to me why. 2 people need more time. Nobody needs help. 3 people need more time. I'm actually very glad that this semester we have the full 16 weeks for undergrad classes, because it's really nice to be able to take this time, that we install things, we make sure that everything works. Whereas last semester we just kind of had to run to it and start doing homework straight up, and it was very hard. If you're having difficulty linking your compiler to the code blocks, it might be easier to just reinstall code blocks with the compiler included. That's kind of a my bad. I should have given you the direct link to the one that includes the compiler. It kind of escapes me that you guys don't have this stuff, because I don't think I've had a computer that doesn't have a compiler in like 30 years. Let me get the direct link of what might be the best option for most people. If your computer is a 32-bit computer, you will know it. If it's very old, then you would have to pick a different version. Okay, if you have downloaded the program, if you've done the linking of the compiler and everything, the thing you needed to do was to follow the steps. Let me relink the steps here. You are supposed to create a file, clicking on File and New, making an empty file, copying and pasting the code there, saving it with a .c extension. Don't put a space there, don't put a space anywhere, and then pressing F9 to compile and run the program. Yeah, and what Luis is doing, we have a couple of problems. First of all, in Python, it's you're kind of like writing Python because you just wrote print, but this is C. In C, you cannot just write print. You need to write printf. This F has to be there. And the stuff you wanted to print out has to be between double quotes. So Luis, you need to add the double quotes and you need to add the F. That's why I'm saying that the first thing you should do is to copy and paste. Don't manually write it. Copy and paste my code so that you get the F and that you get the quotes. Then you can just modify what's inside the quotes. Now, Soiled Fanatic 80, if you're actually signed up for the class, I need you to type exclamation role, because you don't have the role for the class yet. If you're just here hanging out, it's fine. You don't need to have a role. But if you're signed up for the class, please put the role. Just share your screen or send a screenshot if you have an error, if you have any kind of trouble. I'm certain that the people on the voice channel are happy to help you. I am happy to help you. Danielle is happy to help you. Lots of people are happy to help you. So just do what Luis here did, show us what you're trying to do, and we can tell you what's missing and where. And I understand this is very slow and possibly disappointing for people who already have it all functioning, but I can promise you, leaving your classmates behind now is a bad idea because they're going to be very confused every step of the way. So we need to make sure that everybody follows along these first steps so that we can later go a little faster. If we go a little faster now, it's going to be like one person who passes the class and everybody else is going to be in third opportunity. If you don't need any more time, if it's all good, please click on the green thing and take away the confused face. If you have a question, well, these two people already asked their questions. So I'm hoping there's some progress with the running it. If you press F9 and nothing happens, look at your menus. Maybe it's not F9 on your computer. If it gives an error, like with Luis, please show us your error. Either copy paste the error or copy paste us a screenshot so that we can look at how it's not running. Often people just tell me, teacher, it's not working. And I'm like, I can't help you if you just tell me it's not working. I need to know what it is, and I need to know how it's not working. Also, you don't need to do the role again if you already done it. Luis, you had already done it. You're fine. It's Soiled Fanatic 80 who hasn't done it. Okay, let's see here. Okay, this one's working here. Draco's got it right. And Soiled Fanatic has a role now. So Khair has everything working. Draco's got everything working. Okay, I can see the problem here, Song. You haven't saved the file. You need to save it. So click on the little diskette icon and save it with a name like demo.c, like I was doing. Then you press F9. Or you can press the play symbol, or you can go under build and you can compile. But you have to save the file, just like I did. I need to save the file with the proper extension. Actually, it doesn't really matter in Mac or Linux. I can just call it whatever. Like I could just call it, instead of demo.c, I could call it virus.exe, and I could still compile it just the same. I could even call the output something. Ha! Okay, it doesn't like it. It doesn't like it when it's exe. Let's see if GCC likes it. No, it simply doesn't like it. Okay, so let's move the demo. It used to not matter at all. I'm actually glad they've added some checks here. Let's make it virus C and try to compile. So it understands if I give it the wrong extension now. It didn't used to care. It could be like whatever. It's a good practice to always have the correct extensions on your files. But notice I could compile it into an exe file, even though it's actually not an exe file. It's still the a.out. It's just called different because this computer doesn't really care what the file is called. Okay, Luis has everything under control. Waiting for a couple of other people to catch their rhythm. Don't worry if you can't do this today. You can take all weekend to work on this if you want to, as long as you've done it before next class. But you don't really have to stress on getting it working now. I just want to get a handful of people with everything working so that they can easily help you if you get stuck later on. Okay, Florida's is also working. So now you've gotten the simple program working. So what we could do is we could go to the other chapter 1 files here, and you could just pick a random one. Pick one that looks interesting. Doesn't matter what it's doing. Go to the raw button, copy and paste the whole thing. You can make another file, or you can write on top of the file you already had. Copy and paste the whole thing. It's a lot of code and nobody expects you to understand it. Try compiling that new code you made and try running it. It's going to do something. And next week, we have to understand what it's doing. But this week, we're just happy to be compiling and running our code. So this one seems to be printing a chart that converts from Celsius to Fahrenheit. Then when we have it running, we can try to look at the code, try to understand what's going on here. So apparently this has to do with exercises 1.3 and 1.4 of the book. And if I want to make some changes there, I could make changes. I'm going to add an equal sign between the tabulators. I'm going to recompile. Always recompile when you make changes. And now I've made it slightly different. Of course, this stuff doesn't align here anymore because I've added a new tabulator there. So let's modify it again. And you can just mess with the code. It doesn't matter if you break it because you don't really need to understand it yet. We're just practicing compiling. So let's add another tabulator here. Anytime you make changes, remember, if you just run it, it's not going to be the modified version. You compile, and then you run again. Now I can see that it's almost good, but my little spacer thing is too short. Compile, and I run, and it's a little bit better. This far thing is still kind of outside, but it's okay. So you can modify, compile, execute, modify, compile, execute. Then you can also try to on purpose break it. So go here and look for what might be reasonable stuff. Maybe if I take this double quote off, horrible things should happen. I took away the double quote. I will compile, use the other compiler, and it tells me that I have an error. It tells me that I have an error on line 13, that there's a double quote missing. So if I go to my editor, your editor should be able to show you the line numbers. Just like in code blocks, you can see the line numbers on your little screenshots. It says what line the problem is in. Line 13 has a problem. The quote doesn't close. You can also notice that my editor is changing the colors. When the quote closes okay, the code looks better. When it doesn't, it looks worse. So if I fix it and I compile, everything's wonderful again. Same thing, if I break this comment, it's not a comment anymore, it's a division now, I get an error. And it marks here with this little thingy where the error is, and that's exactly where I put the error. So if you manually insert errors to any random code, you can get used to what will it look like if you make a mistake. And it's going to be easier to detect those errors. Like, for example, what's going to happen if I take away this include here? If I just do the main, I have an error. It's saying that I'm implicitly declaring a library function, and it says I need to include the header. Okay, so I need to include the header. It apparently isn't optional. I need to include the header, and then I can compile again. So this is a really good practice for what do the errors look like, and how do you detect where the error is. Okay, now Brian here is trying to do something very interesting. Let's take Brian's code and try to fix it. He wants to print out the numbers A, B, and C multiplied together. So let's make a code for this. First, we include the library that we know isn't optional. We need it for every printf. We're going to make a main. Our main is going to return a 0. And then we want to do what Brian's doing. We have an A, it's worth 8. We have B, that value is 10. And I have a C with the value of 20. Then I want to know by a printout what their product is. I'm going to put the new line there. And now if I want to print variable values, I need to say here, I am going to print an integer. So remember from last time, %d or %i is going to print an integer. Then I need to say, what's the integer I want to print? I want to print a times b. My shift is horrible. Come on. A times b times c. That's the integer that I wish to print. I save, I compile, and I execute. The product of those A, B, and C is 1,600. So what I did is I put the %i, remember it could also be a %d, and that's how you print the value of an integer variable. All of this is covered in the first chapter of the textbook, and we're going to be discussing it in great detail in coming weeks. Any other minor thing you want to clarify now, we can do it. I don't want to go into complicated stuff because we lose people when we go into complicated stuff. But I want everybody to be comfortable with using their code blocks, copying and pasting code, modifying the code, explore the different files in the GitHub, especially the ones in the chapter 1. Pick some, try to read them. Don't worry about whether you understand them yet. Try to think about what kind of artificial errors you could put there to move them, because this is a lot of code and we need to be able to work with all of this code with just chapter 1. So the more familiar you get with it, easier your life is going to be. The other goal for today is practicing how do you put stuff in your own GitHub repository. So I'm going to go here to the beginning of my repository. And remember last time we were working in the intro folder. So now I have all these C files here and they're not in my repository. So let's go to my GitHub folder. Let's go to C and let's go to intro. Apparently I never sync here, so let me sync here. Yeah, I did it all on the browser last time. So I'm gonna go to the intro folder. It only has a demo.c that we did last time that prints some variable values. I'm going to move here the Brian file and the virus file. And let's also move here the demo file, but we're gonna call it demo2. Because I don't want to overwrite the old one. Now, you could do this like we did it the last time. You could just go to the website here and you could create new files over here. So I could just go to create new file, put my code, and upload it. It makes more sense for you to install GitHub on your computer. How to install Git on Windows. Installing Git on Windows step-by-step tutorial. So here it explains exactly what you're going to do to install GitHub on your Windows. You can make it, okay, I'm copying and pasting where it doesn't belong. You can make it so that you can use it from the command line, which is largely what I am going to do now. Or you can use like a thing that looks like the Windows Explorer. That's the GitHub Desktop. And I'm going to show you guys also what that looks like on the Mac. So if we're using the GitHub Desktop, we get this little file thingy here. I'm going to go to where we just were. I am in current repository C, and it's detected that I have all these new files and changed files that don't correspond to the same stuff that we have on the website. So I am going to tell it we're going to ignore some of these files. Some of these files, apparently, we are going to update them. When I want the web repository to reflect the changes, I'm just going to have to tell here, what are these updates about? Stuff I forgot to update and the week number 2 examples. I press commit to main. Then I need to press on push origin. And what's going to happen now is on the web, anybody looking at intro, if they reload the page, all those new files are there now too. They were updated 14 seconds ago, and they were part of the pending updates. So I can go look at the pending updates. It explains here that it's the stuff I forgot to update and the week 2 examples. And we can see for every single file what the changes were. And if it was a new file, it's all changes, nothing but changes because the file didn't exist before. So our virus.c is also listed there. So now all that stuff is here. So I think it would be very valuable that while you're also practicing how to create files, compile them, and execute them in code blocks, you would try to figure out how to put files in your own repository without uploading them on the browser and without creating them in the browser. So try to install Git on your Windows machine and then either use the desktop one where you get like little windows and you can interact with your files, or you could do it from the command line. I'm going to explain how to create the chapter in a second, chapter 1 in a second here. I'm going to make a little change here. Actually, I'm going to show the chapter thing here. So I'm going to make a week 1 folder, and I'm going to make a week 2 folder. This is Mac and Linux. You could create the folders by clicking on Windows if you want to. Then I'm going to move the Brian C to week 2. I'm going to move Demo C to week 1. I'm going to move Virus C to week 2. And I'm going to move Demo 2 to week 2. And I want it to call Demo C. Then I'm going to ask Git, what have I changed? And it tells me I've moved this file, I've changed this file, I deleted these files, and I'm creating new files. So now I have to say that I want to add the week 2, I want to add the week 1, and I want to add all the .c files that are in there. If I don't want it to talk to me about this Python thing anymore, I could also edit a file called Git Ignore, and I could tell it that I don't want any Python files, and I don't want any backup files, and I don't want any out files to be in my Git. I could add the Git Ignore into my repository. I could check the status again. I also have the Biblia. I don't want it to go there because it's not my copyright. So let's add that to the Git Ignore as well. So that text file in particular, I don't want to send it to the public repository. Okay, then I will send this stuff in Message is going to be moving stuff around, and then I will push it. So now if I go to my GitHub again, let's get us a browser window here. If we go back to my C repository and we look at the code, if we go in intro, I now have two sub things here, and now I made a mistake. I was supposed to edit my Git Ignore in the main, so that was actually dumb of me. So I should do the Git Ignore here. Okay, we already had stuff in here, so I'm just gonna move here whatever I put into the Git Ignore. I will add the main Git Ignore. I will get rid of the intro Git Ignore. I'm gonna make a note that I made a second ignore file by mistake, and I'm going to push it. Okay, so now there isn't a Git file there. I have the week 1, it has the demo. I have the week 2, it has the new ones, but the old ones stuck around because I didn't remove them. So now if I go back to intro and I want them to be away from the repository, they're not in my local copy, but they are there. So I could try to get rid of them. They were kind of like ghost files because I already moved them, but I never told the repository I didn't want them. So now if I refresh here, the ghost files are gone. If I want to make a new file from the web thing, that's relatively easy. I am just going to go to create a new file. I'm going to type here subfolder for the folder name that I want to, and then I can make my new file in there. I can put here whatever I want to put there. It's a little uncomfortable to program here because it's so easy to make a little mistake. Luckily, GitHub is using the colors to make it a little easier to remember if everything is properly written. I will commit my new file. So now week 2 has a subfolder that contains another demo.c. So these are our goals for this week. Practice compiling in code blocks or whatever compiler you happen to have on your own computer. Practice uploading stuff directly from your computer to your repository without having to upload it here. You can upload it here in an emergency if you just can't figure out GitHub, but it would be a better idea to locally install Git in Windows and to be able to log into your GitHub account from your local Git installation. Everything, of course, depends on the version of the operating system you have and of the operating system you have. But what I would need you guys to be able to do in a couple of weeks is to create subfolders for the different homework I'm going to be assigning you. And if you want to make like practice things, you could put them in like a demo practice intro folder. And then eventually we're also going to have a folder for your final project. So it would be very helpful to be practicing now with like toy examples so that you won't be confused later on when we actually need to do this stuff. Also, let us revisit the textbook thing. So I've asked everybody to go download the textbook. I just re-downloaded it again. It's in my downloads. Let's rename it the C programming, whatever. Let's call it KR-PDF, and let's put it on my desktop. To take a look at the book. If you don't have it yet, it's really important you go download it. Please, please, please. It's a pinned post on the Discord channel. You need this book, just as you need the reference card, which I have also provided. That's also linked on the course website. And what would be a wonderful thing to start doing before next class is you, little by little, reading this book. So whenever these guys here, they'll go further than the first chapter unless you're really enthusiastic. Whenever they say to write code, write the code. So let's go look at the very first example. Here they introduce things. You will read all of this. You will read all of this. You will read all of this. Then look, they want to make a program that prints hello world. That's just like the program we already made. So it says this is what the program should look like. So we are going to go to our editor, which in your case is going to be the code blocks. In my case, I'm just using my Emacs, which is a bit 80s, but it's still lovely. So you're going to open your editor, and I would recommend you to be in your repository so that you could very easily upload all the practice you're doing. I'm going to go here into week 2. And I am going to make the first example of chapter 1. So that's going to be on page 6. So I'm just going to call it page 6.c. And I'm going to type exactly what these guys say I need to type. I need to type include stdioh. I need to be very careful that every single symbol is exactly what they want and is exactly positioned as they want. And then when I understand why things are where they are, then I can start moving them around. I will type exactly every single symbol they tell me to type. Then I will save it. They are compiling with CC. I will compile with GCC. You guys compile with your Go code block. It gave a warning because something defaults to int, but it's fine. Warning's fine. I have an a.out that prints exactly this hello world stuff, and they say I'm going to have an a.out. On your computer, it's going to be an a.exe because you're in Windows. Okay, so they explain line by line. What's this include for? The whole program is here. All the explanation is here. Don't type these explanations. This is the program. This is the explanation. Line by line, they explain every single thing. They will also explain what kinds of things would produce errors and what other ways you have to do this. So I would ask you, I'm not going to force you, I would ask you to try to do these exercises, the 1.1 and the 1.2. They're very close to what I've already asked you to do, so that next week we could start working on this section 1.2. Here, this is exactly the stuff I was showing you guys before that produces those little tables of Fahrenheit and Celsius. So that's all here. So please start reading the book and start trying to put some hello worlds in your repository so that you can go little by little. Here, all the %d stuff is explained. It's asking you to make little changes. These are exactly the changes that I already had in the code that we were talking about. And next week, we need to talk about the for loop. We need to talk about a while loop, which is going to be here later on. This is a while loop. We're also going to talk about conditions, which are these ifs, and we're going to look at how to represent